Alright, hi everyone. This is my little tutorial on how to measure the bridge properties as we did in the Wilfava 2024 workshop. I know this view that you're seeing right now is probably a little bit confusing at first, so let me explain what you see and what we're going to do. So on the right hand side here we have an Excel file already open that will take the data that we want to gather today. So you can see we want to measure the rocking and bouncing frequency of the bridge without a mass attached first, and then with a mass attached, and the value of this mass, so the weight of the small magnet that you see on the left hand side attached to the vise, is 0.16 grams. So that's entered here in kilograms. We're going to use those two values, so the rocking frequency without a mass and the rocking frequency with a mass, to calculate the effective rocking mass, so how much mass is actually moving during the rocking motion, and same goes for the bouncing mode. Alright, so that's the goal. What do we have as equipment? I'm going to walk out of frame, so you're probably not going to see me, but you can look at the video stream. So we have a measurement microphone. This is a very cheap electret microphone, about 60 cents or something. Doesn't need to be anything special for this. We have a bridge, obviously. It's clamped in a heavy vise. This is much heavier than 2 kilograms, so it's orders of magnitude heavier than a bridge and should pose no problem for this measurement. And then we have some super glue, and as I said, a small magnet with weight of about 0.16 grams. If you don't have a magnet that's exactly 0.16 grams, no problem of course. Just if you use a heavier or lighter magnet, they should be in the range between 0.1 and let's say 0.3 grams or something, nothing much lighter or much heavier than that. And you will of course have to change this value in the Excel table over here appropriately. Alright, so let's start measuring one rocking frequency. I have Audacity already open down here, as you can see. It's just my choice of software. It's open source and free, so I like to use it, but as you know, there's a lot of options for this. As a point of note, you shouldn't cut your fingernails before doing this, as I foolishly did, so it's going to be a little bit harder for me to get a good plug on the bridge, but I'll try my best. Alright, let me clear this off and start a measurement. So now I'm simply recording with the microphone over here. I can tap it with my finger to test that it works. Alright, we can see it works. And then I'm going to pull it up close to the bridge without actually touching it, of course, and try to plug with my fingernail on the other side. Alright, as you saw, I like to do multiple measurements just to make sure and try to get a good snap on there. Let's see, I thought the last 2 or 3 ones were kind of okay. So in Audacity, what you have to do is select a sufficient time frame so it can't be too short. And just by clicking and dragging with the mouse cursor, then you go to Analyze and Plot Spectrum. Oh, as you can see, there's a quite confused signal, so I didn't get a good plug after all. We could guess that maybe the rocking frequency is somewhere in this hill, but we really don't know. So let's ignore this plug for now. Go to another one and see if this one turned out better. We're looking for a relatively clear signal, especially around the frequency that we expect the bridge to be rocking. So this would be quite clear. Around 3.4 kilohertz, we have a rocking frequency for this bridge. And let's see if this is confirmed with another plug. This one is a little bit, it could also be this, right? So for this measurement, I wouldn't be too sure. If I was doing a real measurement, I would probably repeat it and try to get a bit of a better plug on there. But for demonstration's sake here, let's just accept 3.4 as our value. In real life, I would repeat this measurement. I'm going to enter it in here and then do the same for the bouncing mode. So similarly, let me delete the old measurement and start a new one. This time I'm going to hold up the microphone to the top of the bridge like this, so that we more so capture the bouncing mode, as we like to do. And then let's do another plug. Okay. See, select some amount of time of spectrum, and then we seem to have a result at, let's say, 6.2 kilohertz. Let's see if this is confirmed by another one. Looks pretty good. 6.18, 6.16 for both of them. It's a bit more confused. That shows the same. 6.18 will be our measurement for F bounce. Alright, now we're going to repeat the same measurements just after attaching a mask to it. As I showed you earlier, in this case I'm going to use super glue for this, which might not be the most convenient for some people. To some bridges maybe you don't want to glue something, but we found that this is, for now, the only way that I know of that is surely attaching the magnet well enough that it shows up in the measurement. So I don't know how well I will be able to show this. Let me just put a small drop. Of course, it doesn't need to be much. Onto the bridge and the magnet. And glue your finger to it. Great. Okay, I guess all the glue went on my finger. Okay. So now there's a small extra mass attached to the top of the bridge, which we assume to shift the frequencies of rocking and bouncing down due to mass load. Alright, sorry about that. I had to do a quick cut here as my laptop was too slow. But in the meantime, I managed to attach the mass properly to the bridge. So now we can repeat the rocking frequency measurement like this. Remember to start the measurement actually. Okay, let's see. My plugging is really not that great today. You will have to do better, but for tutorial's sake, I guess it's fine. Alright, and we have a downshifted peak at, let's say, 2 point. Gonna make this a bit wider in order to be able to assess it more. This would tell me 2.998. Let's see if this one would confirm it. It's a bit unclear. It's more like 2.9. As I say, the absolute values in this tutorial could probably be better. This is relatively clear, 2.9. We'll just take this as our value for now. Of course, I would do it a little bit more thoroughly, usually. Alright, next we want to measure the bouncing frequency with mass attached. So I'm going to start another measurement. And this time hold up the microphone to the top again. I don't like to hold it right above the magnet as you see me doing right now. I don't know. I think that might cause problems, so I just have it slightly to the left over here. Maybe it doesn't make a difference. Right? See? That's well-defined peak, 5.8 kilohertz. 5.8 kilohertz. And 5.8 kilohertz. So that's our result for rocking with mass. And then the two formula over here give us the effective rocking mass and the effective bouncing mass. You should note that I have a times 1000 in here, so these results are in grams. Just for me, it's a little bit easier to imagine it like this. Of course, you can remove this to express it in kilograms. This would be more scientifically appropriate, I guess. All right, so this is bridge measurement, a quick overview. Thank you.